Welcome to The Explainer. Today, we're diving deep inside your computer's processor to look at the secret weapon that makes everything feel so incredibly fast. We're talking all about register organization. But first, let's start with a question. What do you think is the biggest traffic jam inside your computer? The answer probably isn't what you're thinking, and it gets right to the heart of a fundamental problem in computer design that engineers have been battling for decades. Take a look at this number. 3 billion. That's roughly how many instructions a modern CPU can chew through in a single second. It's a speed that is just mind-boggling. And while that's the source of all your computer's amazing power, it also creates a gigantic problem for the whole system.
So here's the problem in a nutshell. Your CPU is like a world-class sprinter, just bursting with speed, ready to go instantly. But the data it needs to work on, that's stored in main memory, your RAM, which in comparison is like a supply warehouse that's miles and miles away. For that sprinter, the time it takes to just go get the data feels like an absolute eternity. So how in the world do engineers solve this massive speed gap? I mean, you can't just move the warehouse closer. But what you can do is give that sprinter a tiny, personal, and ridiculously fast workspace right there on the starting line. And that little workspace? That's a CPU register. The technical definition is pretty simple. It's a small, super high-speed storage spot built directly into the processor itself. And when I say high speed, I mean it. Accessing a register is hundreds, sometimes even thousands of times faster than fetching data from your main memory. It's the fastest memory in your entire computer, period.
You know, the best way to think about it is with this analogy of a workbench, right? If the CPU is a master craftsman, the registers are all the tools and parts laid out perfectly within arm's reach. Everything it needs for the job it's doing right now is right there. No wasted time walking over to the supply room.
Of course, not all the tools on this workbench are the same. Registers are organized into different types. You've got your general purpose registers. Think of these as your hammers and screwdrivers, the flexible workhorses you use for all sorts of calculations and moving data around. Then you have special purpose registers, which are more like precision tools, each with one very specific job. And finally, status registers are kind of like a little clipboard, keeping notes on what just happened.
This table really shows you where that workbench fits into the bigger picture. This is the memory hierarchy. Right at the very top, you have registers. They're basically instant, but they're also incredibly small. We're talking kilobytes of space. A step down is the cache, which is like a tool cart you keep next to your workbench. A bit bigger, a bit slower. Then comes the main memory supply room, and way at the bottom is the massive warehouse of your hard drive or SSD. It's a simple trade-off: speed costs space. And it's really crucial to get the difference between registers and that next level down, the cache. Registers are inside the actual processing core, holding the data for the operation that is happening this very instant. Cache, on the other hand, sits nearby and tries to guess what data the CPU will need for upcoming operations. It's the difference between the tool in your hand versus the tool on the cart right next to you. Okay, so we know what they are and where they fit in. Now let's see these registers in action. We're going to look at how they're absolutely essential to the CPU's most fundamental rhythm. See, at its core, a CPU just does this three-step dance over and over again, billions of times a second. It fetches an instruction, it decodes that instruction to figure out what it's supposed to do, and then it executes the command. And guess what? Registers are critical to every single one of those steps.
First up, the fetch step. Here, a special purpose register called the program counter is the star of the show. Think of it like a bookmark in a giant instruction book. It always holds the exact memory address of the very next instruction the CPU needs to go and grab. The moment that instruction is fetched, bam, it's immediately loaded into another key special purpose register, the instruction register. Its job is to hold on to that single instruction while the CPU moves on to the decode step and figures out what it's all about. And finally, the execute step. This is where the magic happens. The data needed for the calculation is pulled into those general-purpose workbench registers. This gives the CPU's math brain, the ALU, instant access to the numbers it needs to do the calculation and pop the result right back into another register. All right, that's a whole lot of microscopic action happening at an insane speed. But why does any of this complex little dance matter to you on the devices you use every single day? Well, it matters because this super efficient workbench system is what makes your technology feel fast and snappy. You know that instant app launch on your phone? Or how you can seamlessly flip between a dozen programs on your laptop? Or those buttery smooth high frame rates in your favorite game? All of that is a direct result of registers making sure the CPU never has to wait around. At the end of the day, it's really that simple. The raw speed and incredible efficiency of these tiny, invisible components translate directly into the performance that you can actually see and feel. A well-organized system of registers is the bedrock of a powerful, responsive user experience. So let's wrap this up. What have we learned? Registers are the unsung heroes of processing speed. They are the CPU's personal workbench, the fastest memory there is, and they're what makes that whole fetch, decode, execute cycle even possible at today's speeds. And their efficiency is something you feel every single time you tap, click, or swipe. And that leaves us with one final question to think about. We're living in an age of AI, big data, and applications that are getting more complex by the day. The demands we're putting on our processors are just exploding. So you have to wonder, what will the workbench of tomorrow's CPU even look like? How will this tiny fundamental component have to evolve to keep up with the future?